Hello students, today I am going to start class 9th chemistry and the name of the chapter is matter around us pure? In this chapter we already completed one sessions. On that session we discuss about the characteristics of matter, definition of matter, the different type of the matters and pure substances. Again we are classifying the pure substances as elements and compounds along with the characteristics and type of the compounds we discussed in last session. So in this session I am going to discuss the next concept of your chapter, that is mixtures. So let's start the next concept of your chapter, that is mixtures. So what do you mean by mixtures? Before going to discuss about the mixtures, you need to understand the objectives you are going to learn in this class. First one, the definition of mixtures, and next one, examples for mixtures, characteristics of mixtures and different type of the mixtures like homogeneous mixture and heterogeneous mixture. Again the definition of homogeneous mixture, characteristics of homogeneous mixture, similarly definition, example and characteristics of homogeneous mixture, along with the least different solute solvent combinations. Compare the properties of solution, suspension and colloids. Last 2 points we will discuss in the next sessions. So just we need to concentrate on the first learning object of the today's class. So mixtures, what do you mean by mixtures? We already learned in the previous classes matters are classifying as a two types. First one is on the basis of pure substances and second one is on the basis of mixtures. Matters were classifying as the two types, pure substances and mixtures. Again that pure substances were classifying as two types, elements and compounds. Elements and compounds, these two things were already discussed in the previous classes. Now mixtures are classified as a two types, homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Let's start what is the meaning of mixture and how the homogeneous mixture is different from heterogeneous mixture. So what is mixture, what are its types and examples of mixture? So mixture is a substance, it is also one kind of the substance which consists two or more elements, or compounds. All that compounds or elements do not chemically bonded together. So mixtures are the substances which is consisting two or more elements or compounds, but that compounds and elements are not chemically bonded together. See here, definition is given. A mixture is defined as the combination of two or more substances. A mixture is defined as the combination of two or more substances. The substances in a mixture can all be solids like the mystery mixture, all liquids like salad dressings, all gases like air, or the combination of solids, liquids and gases. A mixture is simply a combination of two or more substances. Here the two or more substances are combined together, but they will not form any kind of the chemical bondings. So mixtures are the substances which consisting two or more elements, either it may be consisting two or more elements or compounds, but these compounds or elements do not combined by chemical bonding. Okay, see here, next one. A mixture is a substance which consists of two or more elements or compounds not chemically combined together. It means they will not form any kind of the bonding here. It's just a combination only. We are going to combine two or more substances, but these substances will not be form any kind of the bondings. All solutions are mixtures. All the solutions are mixtures. The various substances present in a mixture are known as constituents of the mixtures. Constituents of the mixtures. See here, one more definition is given. A mixture is a combination of two or more substances in which each pure substance retains its individual chemical properties. A mixture is a combination of a mixture is a combination of two or more substances. So what kind of the substances we are going to add here, or we are going to combine here? The substances can may be all the solids, can may be all liquids, can be all gases. It means the substances, either it may be solids or liquids or gaseous, can be a combination of solid, liquid and as well as gases. Either we can add two solid substances, we will get a one kind of the mixture. It means solid mixtures. If we are adding two liquid mixtures like water and oils, if we are adding two gaseous mixtures like oxygen and carbon dioxide, so all these are the different type of the mixtures. And we are having one more type of the combination, whether it may be the combination of solids, liquids and gaseous also. So see, some examples are given for mixtures: tossed salads, a bowl of cereals, oils and vinegars. So these are the some of the examples for mixtures. Next one, pizza. Pizza is also one of the example for mixture. Trail mix, Halloween candies. These are the some of the examples for mixtures. And most important examples for mixtures is air. Air is a mixture of gases, like, as we already know that air is consisting number of the gases like oxygen, nitrogen, argon, carbon dioxide and some of the dust and moisture contents also. So air is the best example for mixture. Air is consisting different type of the gases like oxygen, nitrogen, argon, carbon dioxide, right? Next one, gunpowder. If you are considering the gunpowder, it's a mixture of gunpowder is a mixture of potassium, nitrate, sulfur and charcoals. So gunpowder is a mixture of potassium, nitrate, sulfur and charcoal. Next one, brass is a mixture of copper and zinc. Brass is a mixture of copper and zinc. By the combination of copper and zinc, we will get the brass. The various substances present in the mixture are called as its constituent or components of the mixtures. Let's see the characteristics of mixture. It is an impure substance. We already know that mixtures are impure substances. Pure substances are elements and compounds. Pure substances are elements and compounds, but impure substances are obviously mixtures. So it is an impure substance, and these substances do not have any kind of the formulas. They can be mixed in any ratios. For example, in compounds, all the chemical compounds are having particular ratios. Each and every element and each and every atom has a particular number of ratios or number of volumes. In the definite proportions only we are combining the elements or atoms in the given compound. But in mixtures, they do not have any particular formula. They cannot be have definite ratios also. It means we can mix the two or more different type of the substances in improper ratios also. Next one, the properties of mixtures are the properties of constituents or components. Constituents can be easily separated by physical method like heating, drying, crystallization and distillation. So these are the some of the methods we are going to use to separate the constituent particles. Constituent particles means the components which are already present in the mixture. That components we are going to be separate with the help of the heating or drying or crystallization or distillation processes. It is either homogeneous or heterogeneous. So mixtures, again we are classifying the mixtures as a two types. First one is homogeneous mixture and second one is heterogeneous mixture. See here, some more information is given about the mixtures. A mixture is made up from different pure substances, whether it may be the mixture of the elements or compounds or both, that are not chemically joined. It held together by physical forces, not chemical. It means it do not shows any kind of the chemical properties, or it do not forms any kind of the chemical bonding between the two substances. And third one is can be separated physically by filtration or evaporation or distillation. Next one, examples for the mixtures is ocean water, air, soil, vegetable soups. So these are the some of the examples for mixtures. See, some more information is given about the mixtures. Most substances that you find in nature as well as most human made substances are mixtures of one or more pure substances. So all the things what we are observing around us, all that substances, whether it may be plastic or liquid substances or gaseous substances or solid substances, most of the substances what we are using in day-to-day life, all these substances are made up of the mixtures only, whether it may be the mixtures of elements or it may be the mixtures of compounds also. Next one, mixtures can be classified as homogeneous or heterogeneous mixtures. So we are classifying the mixtures as two types, homogeneous mixture and heterogeneous mixture. Next, see the next property, the difference between homogeneous mixture and a heterogeneous mixture is how well the material are mixed together and how uniform its composition. Later we will discuss about this one, homogeneous mixture and heterogeneous mixture. What is the homogeneous mixture and what are the characteristics of both homogeneous and heterogeneous mixtures, we will discuss later. So these are the two types of the mixtures, homogeneous mixture and heterogeneous mixtures. Now see the next concept, that is types of mixtures. Types of mixtures, you already know the mixtures are having two types. First one is homogeneous mixture and second one is heterogeneous mixture. Let's see the first type of the mixtures, that is homogeneous mixture. Homogeneous mixture, this is the first type of the mixture. So what do you mean by homogeneous mixtures? A homogeneous mixture is a mixture of substances blended so thoroughly that you cannot see individual substances. It means if we are taking water in two different glasses and add that two glass waters in a different container, we cannot separate that water again. It means the two glass water is having the same kind of the chemical and physical properties. We cannot, once we are adding that 2 glass waters in a separate container, we cannot separate that substances. So these kind of the substances are called as a homogeneous mixtures. In homogeneous mixtures, the substances are completely mixed together and we cannot distinguish from one another. They have uniform composition throughout its mass. It has no visible boundaries. We cannot make separate. If we are adding two substances, we cannot make it as a separate substances in the homogeneous mixture. It has no visible boundaries of separation between the various components of the homogeneous mixtures. For example, sugar solution or salt solution, alcohol and water, and next one is soft drinks. So these are the some of the examples for homogeneous mixtures. See here, homogeneous homogeneous mixture can be separated into their components usually by taking advantages of their physical properties such as boiling point and magnetism. With the help of these two properties only we can separate the homogeneous mixtures. For example, saltwater evaporation. Saltwater evaporation. See some more information about the homogeneous mixture. A homogeneous mixture has uniform appearance. It means the whole mixture is made up of the same kind of the substances or same kind of the materials. It look the same throughout the mixture. It means we cannot easily distinguish or you cannot easily classify the substances as a different substances. It means the homogeneous mixture is made up of the same kind of the mixtures only or same kind of the substances only. Has a uniform composition. It has uniform composition, is made up of same type of the particles. All the substances that make up the mixtures are evenly distributed. It can be separated by physical method, and two methods we are using. The first one is by using the magnetic method or by using evaporations or heatings. Last slide only we already discussed, by boiling point and magnetism we can separate the homogeneous mixtures. Let's see some more information about the mixtures. One type of the homogeneous mixture is solution. Solution is also one type of the homogeneous mixture. A mixture made up of two or more pure substances. The particles that make up a solution are too small to be seen. For example, salt water or tea, mouthwash, air, alloy. Alloy is a mixture of the different kind of the metals. We're using different kind of the metals. With the help of different kind of the metals we make a alloys. Next one, a solution is formed when one substance is dissolved in another substance. So solution, each and every solution is made up of the three kind of the substances. First one is solute, solvent and solutions. So homogeneous mixture, solution is also one type of the homogeneous mixture. Solution is nothing but a homogeneous mixture because it is made up of the same kind of the substances. What do you mean by solute? Solute, the substance that dissolves. The substance what we are dissolving, that is called as a solute. Solvent means the substances that does the dissolving. The solvent dissolves the solute. There is usually more solvent than solute. For example, salt Salt is a solute and dissolves in water. Water is a solvent. So water is the solvent and salt is the solute. Here the quantity of the water is always greater than the quantity of the salt, because whenever we are going to make a solutions in that, the solvent should be greater than the quantity of the solvent should be greater than the quantity of the solute. Next one, a homogeneous mixture is a mixture that has only one phase. Only one phase means we cannot make different phases, means we cannot observe the different kind of the substances. For example, once we are dissolving salt or sugar in water, again we cannot observe that salt particles are salt particles are sugar particles in water, because that sugar and salt is completely soluble in water. That's why we are going to observe only one kind of the phase. Its components have a uniform composition and cannot be viewed separately in the mixture. That is why it exhibits uniformity in appearances and properties throughout the mixture. The prefix homo means the word homogeneous. It comes from Greek word, in that homo comes from the Greek word homos means same. It indicates that the two substances combined together blended well to form one uniform mixture in which individual particles cannot be distinguished. So homo means same type and gene means kind. So same kind of the substances, what we are adding or what we are combining the two substances, that two substances should be same kind of the substances. So these kind of the mixtures we call it as a homogeneous mixture. Let's see the characteristics or properties of homogeneous mixture. First one, homogeneous mixture consists of one phase. We already know each and every homogeneous mixture is made up of same kind of the substances. It means the homogeneous mixtures consist of one phases. Matter may exist in different phases. These phases include solids, liquid and gases. A homogeneous mixture only has a single phase. It can be of any of the following combination: liquid-liquid combination like water and alcohol, solid-solid combination like copper and tin, or gas-gas combination like oxygen and carbon, or oxygen and nitrogen, oxygen and argon, or oxygen and helium. Homogeneous mixture is consisting only one phase. See the second characteristics. The combination or the composition of homogeneous mixture is identical. It means the entire homogeneous solution or homogeneous mixture is made of the same kind of the substances. Since there is uniformity in the distribution of the particles in homogeneous mixture, each of its portion has been same composition and properties. Till the end, we are going to observe same kind of the particles should be appear in the homogeneous mixture. See the third property of homogeneous mixture. Homogeneous mixture look uniform in the naked eyes. When we are observing the homogeneous mixture, looks like an identical solution. Identical solution means we cannot make different particles, or we cannot observe different particles in the solution. The first time that you look at homogeneous mixture, you might not be able to distinguish their components since they do not present in any gap. It means whole entire solution is made up of the, or entire mixture is made up of the one kind of the particles, or it is made up of same type of the particles. Next one, fourth characteristics, homogeneous mixtures cannot be filtered. In order to separate mixtures, different physical or mechanical processes may be used. However, if the mixture is homogeneous, the filter or liquid from which is substance has been removed using filter will not be achieved purification. It means if we are taking two type of the liquids, right, it means the two type of the mixtures in the form of liquid we cannot make separate with the help of the filtration. Okay, next one, fifth property or fifth characteristics is most homogeneous mixtures are transparent. All the homogeneous mixtures are transparent except those which are homogeneous solid mixtures. Homogeneous solid mixtures means the formation of alloys. Alloys are nothing but the combination of two or more metals. Expect that things, most of the homogeneous mixtures are transparent in nature. For example, sugar solution or salt solutions. See the next one, different kind of the homogeneous mixtures. Homogeneous mixtures can be solid. We already discussed these things. It may be solid things, or it may be liquid things, or gaseous things. First one, solid. Solid homogeneous mixtures is present in alloys. Solid mixtures is present in the form of alloys. So alloys are the mixtures. Alloys are the mixtures of homogeneous mixtures. Especially all the alloys are the mixtures of homogeneous. It means we are going to combine here the same type of the metals. Alloys. An alloy is a mixture of elements that have characteristics of metal. One example of alloy is steel, which is made up from a mixture of iron and carbon. The steel is prepared from the mixture of iron and carbon. All of the different elements that make up steel are spread evenly all throughout it. So these are the examples of solid homogeneous mixtures. Let's see the next one, liquid homogeneous mixture. A liquid homogeneous mixture is called solution. A liquid homogeneous mixture. So which one is the liquid homogeneous mixture? Solution is the liquid homogeneous mixture. A liquid homogeneous mixture is called solution. A solution is a mixture of two or more things that are mixed up together evenly. In a solution, the substance that dissolves another substance is known as a solvent. On the other hand, the substances that is dissolved is called as solute. In mixture, the solvent is usually present in a greater amount than the solute. We already discussed in the previous slide. Solvent is always greater than the quantity of solute. Solute is the, whether the solute, it may be in the form of sugar or in the form of salt or in the form of three different ways like solid, liquid or gaseous. And solvent is always in the form of liquids. When we are combining these two, what we will get? Solution. For example, here salt is a solute, water is the solvent, and salt water is the solution. By adding salt in water, we will get salt water or salt solution. Okay, see the next one, that is gaseous. Gaseous homogeneous mixtures. Gaseous can be homogeneous mixtures too. The air that you breathe in homogeneous mixture is made up of nitrogen, oxygen, carbon dioxide and other gases, but you cannot tell the difference between them when you are breathing, since they are mixed up and spread out evenly in the air. So air is the one type of the gaseous homogeneous mixture. That air is made up of different kind of the, or it consists of different kind of the gaseous substances like nitrogen, oxygen, carbon dioxide, helium gases and some of the moisture and dust particles also. So this is all about the homogeneous mixtures. Homogeneous means mixtures means the mixture which is made up of same kind of the substances. Okay, let's see the next type of the mixture, that is heterogeneous mixture. So heterogeneous mixture means the name itself indicates hetero means different and gene means kind. So different kind of the substances are combined together here. So heterogeneous mixtures are those mixtures in which the substances remain separate and one substance is spread throughout the other. They do not have uniform composition. They do not have uniform composition means we are going to observe different kind of the substances in the mixture. It is visible boundaries. We can easily observe the two different kind of the substances and we can easily classify that two substances. It means it have particular boundaries also. For example, sugar and sand. Sugar and sand and and sugar and stones. Next one, salt and stones, milk and soil, blood and starch, mud and water. So these are the some different type of the heterogeneous mixtures. Let's see the definition of heterogeneous mixture. Heterogeneous mixture is a one of that consists of two or more substances. It is non-uniform and the different components of the mixture can be seen. Some examples of heterogeneous mixtures are cereals with milk and salad. Cereals with milk and salad. All the heterogeneous mixtures are made up of the two or more different kind of the substances. In that we do not observe the uniform composition or we cannot observe the same kind of the substances. We can easily separate the heterogeneous mixtures. That's why all the heterogeneous mixtures are having some particular boundaries also. See the next one, some of the information is given about the heterogeneous mixture here. A heterogeneous mixture is consist of visible different substances or states of matter. Substances remain separate. We can easily separate the substances which are existing in the heterogeneous mixture. The different substances in the mixture can be typically be separated easily. By using some of the processes, we can easily classify the substances which are existing in the heterogeneous mixtures. And next, some examples are given here. Iced tea, solid ice and liquid tea, pizza, blood, cereals in milk. So these are the some of the examples for heterogeneous mixture. One type of the heterogeneous mixture is a suspension. Heterogeneous mixture, suspension. Suspension is the best example for heterogeneous mixture. Solution is the best example for homogeneous mixture. So one type of the heterogeneous mixture is suspension, made of larger visible particles that do not dissolve. Solid particles will settle down and separate over time if left alone. It means when we are dissolving insoluble particles in water, like stones or marbles or rocks in water, when we are dissolving these kind of the solid substances in water, it cannot be soluble in water. It means they are finally settled down at the bottom of the container. Easily we can classify the substances like water and solid substances, whether it may be stones or marbles or rocks, by the filtration method. It means all the heterogeneous mixtures we can easily classify, and we can observe the boundaries also. We are going to be observe the different type of the boundaries. We are going to be classify the heterogeneous components which are existing in the heterogeneous mixtures. Next one, examples: pulpy orange juice, tomato juice, sand in water, and check mix. Heterogeneous mixture. The word itself, it indicates, the prefix hetero indicates difference. Hetero means, again, the same word, it is also come from or derived from the Greek word, in that hetero means different, gene means kind. Hetero means different and gene means kind. It means the heterogeneous mixture is a combination of different type of the substances. A heterogeneous mixture consists of visibly different substances or phases. Homogeneous mixture is a one type of the phase. We are not going to observe different type of the phases in homogeneous mixture, but in the heterogeneous mixtures we are going to observe more than two or more than five types, or infinite number of types also, or infinite number of phases also. It means if we are adding different type of the substances, we are going to observe different type of the boundaries also. Two or more parts can be seen. For example, here water, in the first image we are observing water, second image sand. When this sand is dissolved in water, the sand particles are heavier. That's why they are settled down at the bottom of the container. Here you are observing the two phases. First phase is the lower phase of the container, which is consisting sand particles, and upper phase of the suspension, which is made up of, or which consists water particles. The mixture still has undissolved solid particles settled down at bottom, with some particles still floating. The lighter particles are obviously floating on the water, and heavier particles, if the particles are having high density, they are settled down at the bottom of the container. When the particles are having low density, when we are comparing the density of the water, then the light particles are floating on the surface of the water. So this is the best example for heterogeneous mixture. Suspension is the best example for heterogeneous mixture. Okay, see here some more information is given about the heterogeneous mixture. Examples: smoke filled air. The amount of smoke is not uniform inside the air. Granule cereals or trail mix. The individual ingredients such as raisins, nuts and dried nut fruits remains visible even after mixing. Concrete. In the concrete, the components of the sand, lime and water used to concrete it often remains visible. In the concrete we are using different kind of the solid and liquid substances. We can easily classify these substances. So see here some more examples are given for heterogeneous mixture. The first one is like Lucky Charms, Captain Crunch, Granites and Marbles, chocolate chips cookies, chocolates, chips and cookies, sand in water, muddy water and suspensions. These are the some of the examples for heterogeneous mixtures. Some more example is given here: sand and pebbles, oil and water, trail mix, pizza, salad. So these also some of the example for heterogeneous mixture. Let's see the differences between homogeneous mixture and heterogeneous mixtures. So these differences are very important for your examination point of view. See the differences between homogeneous and heterogeneous mixtures. First one, homogeneous mixture have uniform composition throughout the mixture. Heterogeneous mixture have a mixed composition which may be vary from point to point. It means in the homogeneous mixture we are going to observe same kind of the composition or same kind of the particles are existing in homogeneous mixture. In heterogeneous mixture we are having different kind of the particles. The heterogeneous mixture itself, it is made up of the different kind of the substances, whereas homogeneous mixture is made up of the same kind of the particles. Next one, components are not visible to the naked eyes. Here in heterogeneous mixture, components can be seen easily. Homogeneous mixture, the whole mixture is in the same phase. It means all the homogeneous mixtures is having only one phase. The suspension, or it means heterogeneous mixtures, suspension can be of two phases and layers may be separated. Heterogeneous mixtures are having more than two phases also. Homogeneous mixtures is made up of one type of the phases. Heterogeneous mixtures is made up of the more than two type of the phases. Particle size is often at atomic or molecular level. In heterogeneous mixture have large particles in size. And the next difference is components of the homogeneous mixture cannot be separated easily, but the component of the heterogeneous mixtures can be separated easily with the help of filtration or with the help of the magnetic separations also. So these are the some of the differences between homogeneous mixtures and heterogeneous mixture. Overall, homogeneous mixture is made up of the same kind of the particles, and heterogeneous mixture is made up of the different kind of the particles. In homogeneous mixture, we cannot classify the substances or components which are existing in homogeneous mixture, but in heterogeneous mixture we can easily classify or make the separate form of the components from the heterogeneous mixture. And in homogeneous mixture we cannot observe any kind of the boundaries. In heterogeneous mixture we can easily make a boundaries between the two existing components or substances in the heterogeneous mixture. Okay, let's see the next type of the differences, that is the difference between the mixtures and compounds. This is also very important for your examination point of view. See this one, the first difference. This is the difference between compounds and mixtures. First difference, compounds are formed as a result of chemical reaction between two or more elements or compounds. So compounds are formed as a result of chemical reaction between two or more elements or compounds. But mixtures are formed by simply mixing two or more constituents there are no chemical reactions between the constituents or components. It means all the compounds are formed by the combination of atoms or combination of metals or the combination of different kind of the molecules also. In the compounds, all the elements and compounds and molecules are combined by the chemical reactions. They have particular chemical bondings also, but in mixtures they do not have any chemical reaction, they do not form any kind of the chemical reaction, or they do not form any kind of the chemical bondings also. Next one, second, the components of the compound are always present in definite ratio by mass. In the mixture, the components of the mixture may be separate in the any ratio. Third one, the properties of the compounds are entirely different from the constituent. For example, carbon dioxide. Carbon dioxide is a combination of carbon and oxygen. The characteristics of carbon and oxygen is entirely different from the characteristics of carbon dioxide. It means it do not shows the characteristics of the combining components or constituent in the compound. Here in mixtures, the properties of mixtures are same as these of the constituents. Fourth one, compounds are always homogeneous in nature. Mixtures are usually heterogeneous except solution. Compounds formation is accompanied by absorption or evolution of light, heat and electric energy. Heat, light, electrical energy may not be evolved or absorbed during the formation of mixture. And sixth one, melting and boiling point of compounds are usually sharp and fixed. Melting and boiling point of mixtures are usually not sharp or fixed. It means each and every chemical compound has fixed boiling and melting point. At that point only the compound will be get started to boil or get started to melt. But mixtures do not have any fixed melting and boiling point, because we're not going to combine in the proper manner, or we are not going to be combined in the proper ratios. All the mixtures are having different ratios. The combination of the two substances or more than two substances combining in the different ratios of their volumes. That's why they do not have any fixed boiling and melting points. See the next one. The constituents of the compound cannot be separated by physical or mechanical means. They can be, however, separated by chemical methods only. The compounds we cannot be make separate. The constituents or components of the compound we cannot make separate by physical or chemical method, but they can be separate with the help of the chemical reactions only. But here in the mixtures, the components of the mixtures can be easily separated by physical method. Either it may be filtration method or magnetism separation method or drying method. You can use different type of the methods to make the separation of solid or liquid or gaseous substances in heterogeneous mixtures also. So these are the differences between compound and mixtures. In the next class we will discuss about the next concept of your chapter, that is solution. In the next class we are going to discuss about the solution, characteristics of solution, suspension, characteristics of suspension, and the last concept is colloids and its characteristics. Till then, be happy, have a nice day, thank you.